The debris field of 3I Atlas should already exist. 16 fragments minimum. Physics demands it. Yet 3I Atlas appears whole. December the 19th ends this. Either Hubble reveals hidden debris confirming nature, or confirms intact structure proving technology. No official press release distributed through institutional channels. No emergency briefing called at the White House or at the United Nations. Someone who has examined the data from every angle, who has run the calculations multiple times looking for errors, who has considered alternative explanations and found them all wanting. And in that short text, delivered in that calm, steady voice he always uses when he's about to fundamentally change the entire conversation, he delivered what he unequivocally called his final warning about 3I Atlas, the third interstellar object ever discovered, and perhaps the most unpredictable, highly anomalous visitor humanity has ever tracked across its skies. Hit like and subscribe for a more sleepy explanation. For months, astronomers around the world have passionately argued, debated, vehemently dismissed, and often ridiculed the mounting anomalies surrounding this strange, stubborn object. Its inexplicable change in colour from the reddish hue typical of primitive cometary material to colours suggesting different surface composition or different sublimation chemistry. Its unexplained non-gravitational acceleration, velocity changes that don't match what gravitational interactions with the Sun and planets predict, requiring some additional force to account for observed trajectory deviations. Its enormous powerful jets of gas erupting from the nucleus, with intensities that seem disproportionate to the object's size and to its distance from the Sun, where solar heating should be relatively modest. Its puzzling vast anticoma stretching nearly 3 million kilometres in the sunward direction, not away from the Sun as radiation pressure and solar wind should push cometary material, but toward it, defying the forces that create normal cometary tails. And its bizarre high mass loss rate that made absolutely no physical sense for an object of its conservatively estimated size, based on brightness, and on distance, and on assumptions about albedo and composition. But Dr. Kaku was meticulously watching the numbers shift in ways no natural comet should ever behave. Not casually observing, not relying on second-hand reports, actually running the calculations himself, applying the fundamental physics of sublimation and heat transfer and energy balance that any competent physicist can verify independently. And now, armed with new rigorous calculations, updated orbital models incorporating the latest trajectory measurements and the latest images from Chinese orbiters and Earth-based powerful telescopes, he has finally stated what virtually no scientist wanted to hear, but what the mathematics appears to demand. He asserted that the physics simply doesn't add up, that the observed energy required to produce the jets, the mass loss rates, the velocities of the ejected material, the sustained intensity of the outgassing, is impossible for a single intact natural object of that size. That the calculated jets cannot physically be produced by the nucleus we see based on how much solar energy that nucleus can absorb and how efficiently that energy can drive sublimation of volatile ices. And that if 3I Atlas does not appear as a fragmented, shattered cloud of debris on the pivotal date of December 19th, 2025, then the only remaining logical explanation is that we are not looking at a natural comet at all, that we are observing something that was built, something designed, something that operates according to principles that natural objects don't employ. This is the moment when the scientific world sharply split into two distinct factions. Those who fear that Kaku is demonstrably right, that the calculations are sound, and that the implications are unavoidable regardless of how uncomfortable they make us feel. And those who fear what it would truly mean for humanity if he is right, what it would mean about our cosmic isolation, about our technological primitiveness, about our assumptions regarding whether we're alone. Both factions are driven by fear, just different flavours of it. Fear of being wrong about something fundamental. Fear of having to revise worldviews that have been stable for centuries. Fear of what comes next if we're forced to acknowledge artificial interstellar visitors. Tonight, we dive deep into the rigorous calculations that underpin Kaku's warning, into the intense scientific controversy that his statement provoked, and the professional backlash he's facing from colleagues who view his claims as reckless or sensationalist, into the detailed list of 10 anomalies that collectively paint a picture of objects that shouldn't exist if we're limiting ourselves to natural explanations, and into the final stark warning issued by one of the most outspoken and celebrated theoretical physicists of our time, a warning that might be vindicated or demolished in a matter of weeks, depending on what the telescopes reveal. This is the unfolding story of the cosmic object that may soon force humanity to confront a profound truth we're not yet ready to fully grasp. The truth that the universe might be far more populated, far more active, far more watched than we've allowed ourselves to believe. That silence doesn't mean emptiness. That absence of obvious signals doesn't mean absence of intelligence. That visitors might be here right now, moving through our solar system, and that we're only beginning to recognize them for what they are because we weren't looking for the right signatures. From the very moment it was first discovered on July 1st, 2025, 3I Atlas instantly refused to behave like the comets astronomers have spent their entire lives studying. It seemed to come from nowhere, arriving from the depths of interstellar space on trajectory that didn't match orbital elements of any known solar system body. Slipping into our solar system on a hyperbolic path that didn't match any known gravitational lineage, couldn't be traced back to the Oort cloud or to scattered disk, or to any reservoir of comets that formed with our Sun. This was visitor from elsewhere, from another stellar system, carrying ice and rock that condensed around a different star and that was ejected through processes we can only infer. At first, observers saw what they logically expected based on decades of comet observation. A dust coma forming around the nucleus as volatile ices sublimated under solar heating, jets of carbon dioxide erupting from specific regions where ice was exposed or where subsurface pressure built up enough to break through overlying material, and a shape that looked relatively stable, not fragmenting immediately, not showing obvious signs of structural failure, not behaving dramatically differently from solar system comets in those first weeks of observation. But then came the highly anomalous behavior that no one could fully explain using the standard models of cometary physics. As it rapidly approached the Sun during the months after discovery, instead of simply warming and shedding ice like a normal predictable comet, following well-understood sublimation curves that relate solar distance to activity level, its mass loss rate skyrocketed to levels never reliably recorded before in cometary astronomy, producing a massive anticoma stretching nearly 3 million kilometers in the sunward direction, a scale so vast that it defied immediate comprehension, even for researchers accustomed to thinking about astronomical distances. To put that immense scale into perspective, that length is significantly greater than the distance between the Earth and its own moon. The Earth-Moon separation averages about 384,000 kilometers. The anticoma structure extending from 3I Atlas is nearly 8 times that distance. If you could see this structure with the naked eye, if it were bright enough to be visible without telescopes, it would span more than 15 degrees across the sky, 30 times the apparent diameter of the full moon. This isn't small-scale phenomenon. This isn't subtle anomaly that requires careful analysis to detect. This is massive, obvious, in-your-face structure that demands explanation. The Chinese Tianwen-1 orbiter, which was fortuitously positioned to observe 3I Atlas during part of its approach trajectory, successfully captured images revealing enormous powerful jets blasting from the object. Not the gentle diffuse outgassing that characterizes many comets, not the weak sporadic puffs that might appear and disappear as rotation brings active regions into and out of sunlight, but sustained, intense, collimated jets, beam-like structures that maintained coherence across distances where thermal velocities should cause rapid expansion and dispersion. But strangely, and this is where the observations started contradicting what cometary physics predicts, even with such violent sustained eruptions, there was no confirmed fragmentation. The nucleus appeared stubbornly intact, unbroken, and whole in images that should have revealed cracks or separated fragments or the debris field that forms when a comet breaks apart under the stresses of intense outgassing. When you're expelling that much mass that violently, when internal pressures are building to levels that drive such powerful jets, natural comets typically can't maintain structural integrity. They crack, they split. They fragment into multiple pieces that gradually separate as differential forces push them apart. 3I Atlas wasn't showing that, wasn't fragmenting despite activity levels that should have torn it apart. That was the first indication that something fundamental about this object didn't match our models, that either the object was structurally much stronger than natural comets typically are, perhaps solid rock rather than the loosely consolidated rubble piles that most comets represent, or something else was happening that our natural explanations weren't capturing. Meanwhile, other sensitive instruments recorded a distinct colour change as the object's activity increased. Spectroscopic observations showing shifts in the reflected sunlight that indicated changing surface composition or changing dust properties or changing gas emissions. A measurable velocity increase beyond what gravitational acceleration from approaching the Sun would produce, non-gravitational acceleration that required some force beyond gravity to explain, and a significant deviation from the trajectory that orbital mechanics predicted based on gravitational forces alone, deviation that persisted and that accumulated over weeks of observations until it became statistically significant and undeniable. Three key traits that individually would already raise serious eyebrows among researchers familiar with cometary behaviour, but together they formed a complex, unsettling pattern that scientists had only ever definitively seen in one place before. Oumuamua, the first interstellar object whose own baffling non-gravitational acceleration remains fundamentally unexplained to this very day. We still don't know what caused Oumuamua to accelerate in ways that didn't match cometary outgassing models. We still haven't reached consensus on whether it was natural with unusual properties, or whether it might have been artificial. And now 3I Atlas was displaying the same trio of characteristics that made Oumuamua so controversial. By late October 2025, the entire scientific community was buzzing with nervous speculation. Conversations happening in observatory break rooms and in email chains and in Slack channels and in the comment sections of preprint papers posted on Airchive. Something was fundamentally not right about this object. Something was decidedly not natural, and virtually everyone who'd looked at the data closely knew it, even if they weren't willing to say so publicly. Even those too cautious and career-minded to publicly admit it, junior researchers who couldn't risk association with controversial claims, senior scientists who'd built reputations on conservative analysis and didn't want to jeopardize credibility, privately acknowledged that the observations were deeply puzzling. But then Dr. Michio Kaku ran the most critical numbers, and things immediately went from scientifically strange to thermodynamically impossible. From this is weird and we don't understand it to this cannot be natural because it violates fundamental conservation laws that we've tested across billions of observations and that form the foundation of physics as we know it. Dr. Kaku is certainly not a man who casually jumps to sensational conclusions for attention or publicity. He is in fact one of the most highly decorated physicists on Earth, a world-renowned professor of theoretical physics at the City College of New York, co-founder of string field theory, author of multiple best-selling books explaining cutting-edge physics to general audiences, and someone with decades of leadership in pushing the boundaries of theoretical understanding while maintaining rigorous standards of scientific reasoning. So when he sat down to compute the precise physics of the 3I Atlas jets, he did exactly what objective scientists are supposed to do. He identified the observational constraints, the measured intensity of the jets, the estimated mass loss rate based on how much material those jets were carrying away, the distance from the Sun which determines how much solar energy the object receives, and he calculated the required energy output, how much energy per second the object would need to be processing to drive the observed sublimation and to eject material at the observed velocities. And what he found was deeply disturbing. The numbers didn't just fail to match by small margin that could be attributed to measurement uncertainty or to unaccounted factors in the model. They failed catastrophically. The jets were so powerful, so violently energetic, and so sustained that to produce them naturally through solar heating, driving sublimation of water ice and carbon dioxide ice and other volatiles, 3I Atlas would conservatively need to expose approximately 1,600 square kilometers of surface area to the Sun's heat. Think about what that means physically. The surface area determines how much solar energy the object intercepts. Energy flux from the Sun at any distance is known. It's called the solar constant, and while it varies with distance according to inverse square law, we can calculate it precisely for any orbital position. At the distances where 3I Atlas was displaying this intense activity, solar flux was on the order of several hundred watts per square meter. Multiply that flux by the exposed surface area, account for albedo effects and for thermal emission, and for the efficiency of converting absorbed solar energy into sublimation, and you get the maximum power available to drive cometary activity. For natural comet, all the energy driving sublimation comes from the Sun. There's no internal heat source, no radioactive decay producing significant power, no chemical reactions generating heat, no stored energy from formation that's still being released, just solar heating. The energy absorbed equals the energy re-radiated plus the energy consumed by sublimation. That energy budget is fixed and is calculable from first principles. Kaku's calculations showed that producing the observed jets required processing solar energy captured by 1,600 square kilometers of surface. For sphere, surface area equals 4p times radius squared. Solving for radius, if A equals 4pr2, then R to sqrt A4p. With A to the 600 kilometers by 1.619 dement, we get R to sqrt 1.609, 12.57. Gas to sqrt 1.7 ginadro date. 11,270 meters. That's a radius of about 11.3 kilometers, giving a diameter of roughly 23 kilometers. So to produce the jets naturally through solar-driven sublimation, you need comet nucleus with diameter around 23 kilometers. That's the equivalent of a 23-kilometer wide nucleus exposing enough surface to the Sun to intercept sufficient energy to power the observed activity. But here's the problem, the catastrophic, unavoidable problem that Kaku's analysis revealed. Hubble's most detailed images reliably show that 3I Atlas is no more than 5.6 kilometers in diameter. That represents a 16 times mismatch, not 10% discrepancy. Not factor of 2 that could be explained by the nucleus being elongated or irregular rather than spherical. Not something attributable to measurement uncertainty in the size estimate or in the mass loss rate. 16 times. The object would need to be 16 times larger in surface area, and since surface area scales as diameter squared for similar shapes, that means it would need to be 4 times larger in diameter to naturally produce what we're observing. This is colossal, enormous discrepancy that fundamentally collapses the purely natural explanation. A natural comet simply cannot generate more energy than it receives from the Sun, cannot violate energy conservation, cannot magic power into existence from nowhere. A natural comet cannot physically lose more mass than its exposed surface area allows through sublimation driven by solar heating at rates consistent with laboratory measurements of ice sublimation under vacuum and radiation. And a natural comet cannot possibly maintain structural integrity under such violent sustained outgassing, under internal pressures and stresses that should fracture the nucleus, without immediately fragmenting into dozens of smaller pieces, unless it already had fragmented. Unless what we're seeing isn't single coherent nucleus but is actually cloud of fragments that collectively provide the large surface area that the energy balance requires, while still appearing as single object in images that don't have sufficient resolution to resolve individual pieces if they're clustered closely enough. This is precisely where Kaku made the shocking, unavoidable conclusion that would fully ignite the scientific world, and that would make him target of coordinated professional attacks from colleagues invested in maintaining natural explanations. He calculated that for the mass and energy numbers to mathematically make sense, for the observations to be consistent with natural comet physics, 3I Atlas must have already fragmented into at least 16 pieces. That's the minimum number required to provide 16 times the surface area, while maintaining approximately the same total volume and mass. 16 fragments, each about the size that Hubble sees, collectively presenting the surface area needed to absorb enough solar energy to drive the observed jets. Yet the nucleus appeared whole in the available images. Appeared as single bright point rather than as a resolved cluster of fragments. Therefore, and this is the logical step that proved so controversial, the discrepancy can only be explained in 3 ways. Either our understanding of sublimation physics is wrong by factor of 16, which would invalidate decades of laboratory experiments and spacecraft observations of comets, or the object has fragmented but the fragments are too close together for our instruments to resolve them individually, requiring very specific geometric configuration that would be remarkable coincidence. Or something is producing the jets through mechanism other than natural solar-driven sublimation. Through engineered propulsion, perhaps. Through technology, Kaku did not bury the lead. Did not soften his message with careful hedging language that academics typically use to avoid definitive claims that might prove wrong. Didn't attempt to protect his professional reputation by presenting multiple equally plausible alternatives and letting readers draw their own conclusions. Instead, he delivered a clear, unambiguous, precise warning that left no room for misinterpretation. If on December 19, 2025, when the highest resolution images are captured during closest approach to Earth, if 3I Atlas appears intact rather than fragmented, we must consider that it is not a natural comet. Not might consider. Not possibly consider. Not there could be a chance we should think about considering. But must consider. That's language of logical necessity rather than speculation. That statement that if premises are true, if the thermodynamic calculations are correct, if the size estimates are accurate, if the observations of jet intensity are reliable, then conclusion follows inescapably regardless of how uncomfortable or implausible it seems. Why such strong language? Why such definitive claim when scientific culture typically favours caution and hedging? Because a natural body cannot possibly violate the laws of thermodynamics, cannot extract more energy from sunlight than the exposed surface area can absorb, cannot break the sublimation limits established through countless experiments, measuring how fast ice vaporizes under given temperature and pressure conditions, cannot produce jets powerful enough to create 3 million kilometre anticoma without that activity visibly fragmenting the nucleus through the mechanical stresses that such violent outgassing creates. The physics is ironclad. The conservation laws are fundamental. You cannot get around energy balance through appealing to unusual composition, or to exotic ice mixtures, or to any natural variation we know about. Solar energy input is calculable. Surface area is measurable. Sublimation efficiency has upper bounds determined by molecular physics. When the required energy exceeds available energy by factor of 16, you're not in the realm of measurement uncertainty or of modelling approximations. You're in the realm of fundamental impossibility under natural processes. But an engineered object? A spacecraft? A technological construct designed perhaps millions or billions of years ago by civilization that mastered interstellar travel long before humanity even existed? That is a completely different story. That bypasses all the constraints that limit natural comets, because it's not relying on solar heating to power its activity. It has onboard power source, nuclear reactor, fusion plant, antimatter storage, beamed power from external source, something that generates energy internally rather than passively absorbing sunlight. Dr. Kaku explained that technological thrusters, rocket engines, ion drives, plasma propulsion systems reliably produce far higher exhaust velocities than random natural outgassing produces. Natural sublimation creates gas velocities determined by thermal speeds, typically a few hundred meters per second for molecules escaping from warm ice. But engineered thrusters can achieve exhaust velocities of thousands or tens of thousands of meters per second through electromagnetic acceleration, or through chemical combustion, or through other propulsion principles that our own spacecraft use, meaning they require significantly less mass loss to achieve the exact same momentum transfer, the exact same thrust, the exact same effect on trajectory. If you're expelling material at 10 times higher velocity, you need only 1/10 as much mass to produce same thrust, because thrust equals mass flow rate times exhaust velocity. So the observed jets could be produced with much less surface activity, much less total mass loss, if they're coming from engineered systems rather than from thermal sublimation. In other words, a machine could reliably produce these jets without shredding itself structurally, could maintain coherent nucleus while generating enormous momentum flux through the jets, because it's not relying on internal gas pressure building up until it fractures the structure. Instead, it's using controlled propulsion, where the forces are managed and directed through engineered nozzles, and where the structural loads are distributed in ways that natural comets don't achieve. This brings us to the most controversial, career-defining part of his warning, the statement that transformed Kaku from respected physicist, presenting interesting hypothesis, into lightning rod for coordinated professional attacks and reputation-destroying criticism from colleagues. If 3I Atlas is still in one piece on December 19th, if the highest resolution images from Hubble and JWST show intact nucleus rather than cluster of fragments, then the only rational explanation left is technology, not one of several possible explanations, not an interesting speculation worth considering, the only rational explanation. Because all the natural explanations require either fragmenting to provide sufficient surface area, or violating conservation laws that we've verified across billions of independent measurements. and we don't abandon conservation laws lightly. Don't discard fundamental physics just because observations don't match our preferred interpretation. Instead, we revise our interpretation to fit the physics. If natural explanations are exhausted and ruled out, if the thermodynamics genuinely don't permit natural comet to do what we're observing, then we have to seriously consider artificial explanations regardless of how uncomfortable they make us. That's what scientific method demands. Following evidence to conclusions it supports rather than filtering evidence through preconceptions about what conclusions are acceptable. The scientific world immediately erupted in response to Kaku's statement. And this wasn't routine disagreement of the kind that happens constantly in science, when researchers present competing interpretations of ambiguous data. This wasn't polite exchange of papers and conference presentations, where different teams defend their models and let community evaluate the evidence. This caused open war within hours of Kaku publishing his analysis. This triggered coordinated response that had all the hallmarks of protecting institutional territory rather than pursuing truth. Leading astrophysicists who specialize in cometary science vehemently fired back with public statements rejecting Kaku's claims. Quanzi Ye from Lowell Observatory, an institution with long history of comet and asteroid research, stated bluntly, "The comet looks normal and healthy with no sign of fragmentation," pointing to images showing apparently intact nucleus and to spectroscopic observations consistent with typical cometary compositions as evidence that nothing unusual is happening that requires exotic explanations. Brian Cox from the University of Manchester, physicist with enormous public following and credibility from science communication work, noted that 3I Atlas is natural and nothing unusual is occurring that challenges our understanding of comets, framing Kaku's claims as sensationalism that misrepresents what the data actually shows when analysed properly by people with expertise in cometary science rather than by theoretical physicists working outside their specialty. David Jewett from UCLA, one of the most respected planetary scientists in the world, co-discoverer of the Kuiper Belt, someone whose career has been built on careful observation and analysis of small bodies in the solar system, argued that the data was being misinterpreted, that Kaku's calculations made unwarranted assumptions about size or about mass loss rates or about energy transfer efficiency. That more careful analysis accounting for all the uncertainties would show the observations are consistent with natural comet without requiring the 16 times discrepancy that Kaku claimed. Chris Lintott from Oxford, astronomer who leads large citizen science projects and who has credibility from making complex science accessible to public, called the artificial label an insult to planetary science. Framing Kaku's suggestion not as legitimate scientific hypothesis worth investigating, but as disrespectful to the community of researchers who've spent careers studying these objects and who presumably would know if something genuinely anomalous was occurring. And then came the harshest, most personal criticism from researchers publicly accusing Kaku of irresponsibly misleading the public, of using his celebrity status as science communicator to promote sensational claims that actual experts in the field reject, of damaging public understanding of science by encouraging people to believe in alien visitors when natural explanations are perfectly adequate, of harming the credibility of legitimate scientific research on interstellar objects by associating it with fringe speculation about extraterrestrial technology. The attacks were relentless in their intensity, reputation-destroying in their implications, suggesting that Kaku was either incompetent at basic physics calculations or was deliberately misrepresenting the evidence for attention. Highly personal rather than focusing on the scientific arguments, questioning his motives and his integrity, rather than addressing the thermodynamic analysis he'd presented. And aggressively hostile in tone, using language that goes well beyond normal scientific disagreement into territory of attempting to marginalize and discredit, rather than engaging substantively with the claims. But Kaku did not retreat from his position despite the professional cost, did not issue clarifying statements softening his claims or acknowledging that maybe he'd overstated the case, did not apologize for causing controversy or for making colleagues uncomfortable. Instead, he responded with a powerful statement that sliced straight to the core of scientific dogma and that reframed the entire debate. These critics are trained only on comets and asteroids. Add technological objects to their dataset, and they will never confuse a rocket booster with an asteroid again. This was not arrogance from someone dismissing legitimate expertise. This was serious methodological point about training bias and about how the problems we're trained to recognize determine what solutions we consider plausible. Planetary scientists study natural objects, asteroids, comets, moons, planets. Their entire education and career has been about characterizing natural processes, natural compositions, natural dynamics. They're exceptionally good at that. They've built sophisticated models that predict natural behavior with high accuracy. But they're not trained to recognize artificial objects operating in space. They don't study spacecraft propulsion, don't analyze thruster signatures, don't characterize how engineered systems behave when subjected to solar heating and to thermal cycling and to the environment of interplanetary space. So when they encounter object that displays characteristics of both natural comet and artificial spacecraft, their training biases them toward natural interpretation, because that's the category of object they know how to analyze. Kaku's point was that if you showed planetary scientists spent rocket booster, piece of human spacecraft debris orbiting in interplanetary space, they would initially classify it as asteroid based on appearance and orbit, would try to fit observations into natural framework. But once you told them this is artificial object, once they knew to look for technological signatures instead of just geological ones, they would immediately recognize the features that distinguish manufactured hardware from natural rock, would see the regular geometry, the surface properties inconsistent with space weathering of natural materials, the orbital characteristics suggesting recent insertion rather than primordial formation. Same principle applies to 3i Atlas. If you only consider natural explanations, if your training and expertise and entire conceptual framework is built around analyzing comets and asteroids, you'll try to force the observations into that framework even when the fit is poor, even when you have to ignore inconvenient data or invoke multiple unlikely coincidences to make natural explanation work. But if you're willing to add artificial objects to your hypothesis space, if you're trained in physics and engineering and propulsion systems in addition to planetary science, then you might recognize signatures that planetary scientists miss because they are outside their domain of expertise. This was not arrogant dismissal of cometry expertise. It was recognition that different fields bring different analytical tools and different pattern recognition to same data. That theoretical physicists and planetary scientists are both competent in their domains, but that those domains don't fully overlap. That questions about whether object is natural or artificial might require synthesis of expertise from both communities, rather than deference to whichever community claims the object falls within their traditional scope. And Kaku had history on his side, had spent a lifetime bridging gaps between theoretical speculation and physical reality, had made career out of explaining cutting-edge physics to audiences while maintaining rigor and accuracy, had earned credibility through decades of contributions to string theory and to quantum field theory and to understanding of fundamental forces, was not outsider making wild claims without foundation, but was accomplished physicist applying first principles analysis to observational puzzle. Now he was making his boldest, most consequential prediction yet. Prediction with defined timeline for verification. Prediction that would either be vindicated or demolished based on objective data rather than on theoretical arguments. December 19th would show fragments or would show intact nucleus, would resolve ambiguity one way or another, would either validate natural explanation or would force serious consideration of technological hypothesis, whether the scientific establishment wanted to go there or not. While the scientific community argued vehemently in journals and in social media and in conference hallways, Kaku quietly published his list of 10 anomalies, each one documented, each one representing observation that challenges natural interpretation while being consistent with technological hypothesis, each one serving as serious red flag pointing toward unnatural origin when considered individually, and forming overwhelming cumulative case when considered together. First, non-gravitational acceleration, the trajectory deviations that require force beyond gravity to explain. Natural comets show this too when outgassing creates rocket effect. But 3i Atlas's acceleration pattern doesn't match standard outgassing models. The timing is wrong, the magnitude is wrong, the direction relative to the Sun doesn't match what you'd expect from thermal-driven sublimation that's strongest on sunward side and that creates thrust in anti-sunward direction. Second, unusual color change. Spectroscopic signatures shifting over time in ways that suggest changing surface properties or changing emission characteristics. Could be natural, could be fresh ice being exposed as surface layer sublimates away. But the specific pattern of change doesn't match well with how natural comets typically evolve as they approach and then recede from the Sun. Third, carbon dioxide-dominated sublimation. The gas composition showing more CO2 relative to water than typical comets display. Not impossible naturally, comet compositions vary, but unusual enough to note as departure from typical behaviour, especially combined with other anomalies suggesting the composition might be optimized for some purpose rather than being accident of formation. Fourth, anti-solar jets possibly resembling thrusters, the sunward-pointing jets that defy radiation pressure and solar wind. That maintain collimation across distances where thermal expansion should cause them to disperse. That show persistence and structure more consistent with controlled exhaust than with random gas release. Could be some exotic natural configuration, but the characteristics match engineered propulsion better than they match known cometary jets. Fifth, and most damning, the crushing energy contradiction requiring 16 times more surface area than the nucleus provides. The thermodynamic impossibility that forms the core of Kaku's argument. The calculation that can be independently verified by anyone with undergraduate physics background, and that leads inescapably to conclusion that either the object has fragmented, or something beyond natural sublimation, is powering the jets, plus 5 more anomalies in composition, in activity timing, in structural integrity, in trajectory details. Each one alone might be dismissed as natural variation or measurement uncertainty. Together they form pattern that's statistically damning. That requires either stacking multiple unlikely natural coincidences to explain, or accepting single artificial explanation that accounts for all of them simultaneously, and the core scientific establishment knew it even if they wouldn't publicly admit it. No one wanted to acknowledge that the observations might genuinely require technological interpretation. No one wanted to be the person who endorsed claims about alien visitors when those claims might be wrong and might make them look foolish. No one wanted to risk career credibility on speculation that the majority of colleagues rejected. But no one could definitively explain the anomalies away, either through purely natural mechanisms, could offer possible natural explanations for individual features, could suggest the size estimate might be wrong, or the mass loss rate might be overestimated, or the energy calculation might have errors, but couldn't provide comprehensive natural model that explained all the observations without invoking multiple ad hoc assumptions that individually seemed unlikely and that collectively seemed contrived. Which brings us to the single critical date that defines everything. The date that will determine whether Kaku is vindicated or discredited. The date when observations will resolve ambiguity that arguments cannot. December 19th, 2025. The closest approach of 3i Atlas to Earth. The moment when distance is minimized and when angular resolution is maximized, and when the most powerful telescopes humanity has ever built will capture their definitive images. The world now waits, suspended in a state of anticipation and dread for one precise moment. This is the time when the Hubble Space Telescope and the James Webb Space Telescope will be pointed at 3i Atlas with every available instrument. When exposure times will be maximized to gather as many photons as possible. When image processing will be optimized to extract maximum information about structure and composition. When spectroscopy will characterize the jets and the coma with unprecedented detail. If it is fragmented, the truth will be immediately obvious and mundane. High-resolution images will resolve individual fragments, will show cluster of pieces rather than single coherent nucleus, will reveal the separation between components and the distribution of sizes and the relative motions that occur when fragments are gravitationally bound, but not physically connected. The natural explanation will hold firm. The thermodynamic contradiction will be resolved. Yes, the surface area is 16 times larger than single 5.6 kilometers nucleus provides, but that's because there are 16 fragments collectively presenting that area. If it is intact, the implications are profound and devastating to established science. If the highest resolution images show single nucleus without resolved fragments, if the structure appears coherent and whole, rather than being cluster of pieces, then Kaku's argument becomes nearly impossible to refute. Then the scientific establishment will face choice. Either admit that thermodynamic calculations are wrong by factor of 16, which would invalidate fundamental physics we rely on across countless applications, or seriously consider that the object is artificial. This is the date when calculations will collide head-on with reality, when theoretical arguments will be tested against empirical observations that don't care about our preferences, when models will either be validated or falsified based on what actually exists rather than on what we think should exist. This is the moment when the thermodynamic contradiction will face the ultimate test of observation. This is the crossroads of science, imagination, and cosmic humility, where three forces intersect in ways that will reshape how we understand our place in the universe, regardless of which way the observation goes. Science, the methodology that demands we follow evidence wherever it leads, that requires updating beliefs when observations contradict predictions, that insists on reproducibility and verification rather than authority and assumption. Imagination, the capacity to conceive of possibilities beyond our immediate experience, to entertain hypotheses that challenge comfortable worldviews, to ask "what if?" even when answers might be unsettling. And cosmic humility, the recognition that the universe doesn't owe us explanations we find comfortable, that reality operates according to principles that might surprise us, that our current understanding is provisional and incomplete and subject to revision when confronted with phenomena we haven't encountered before. If we clearly see fragments drifting behind the object in the December 19th images, if Hubble and JWST resolve multiple distinct components each contributing to the overall brightness and activity, if the structure is obviously a fragmenting comet rather than intact spacecraft, then the natural explanation holds firm. Science wins in the sense that our existing models are validated. The thermodynamic paradox is resolved through recognizing that what appeared to be single object is actually cluster of fragments collectively providing the surface area that energy balance requires. Kaku will have been wrong about the intact prediction, while being right about the underlying physics. The calculation showing that 16 times more surface area is required remains valid. It's just that the surface area comes from 16 fragments, rather than from some exotic mechanism. The scientific controversy will settle. The attacks on Kaku will intensify with critics claiming vindication and saying, "We told you it was natural, we told you the artificial hypothesis was premature." The public interest will fade as the story becomes interesting comet that fragmented, nothing alien here, nothing to see, move along. If we don't see fragments, if the nucleus stands unbroken and whole in images that should have sufficient resolution to reveal individual components if they exist, then the universe has just whispered something profound to humanity. You're not alone, not shouted, not broadcast with obvious artificial signals that no one could miss or misinterpret, but whispered through the language of physics and thermodynamics and orbital mechanics, through anomalies that accumulate until the weight of evidence becomes undeniable for those willing to examine it honestly. Then the scientific establishment faces existential crisis about methodology and about institutional culture, has to confront that experts in cometary science might have been too quick to dismiss anomalies that didn't fit their models, that theoretical physicists applying first principles analysis might have seen patterns that specialists missed because they were too close to their assumptions. That outsider perspectives sometimes catch what insider consensus overlooks because outsiders aren't invested in defending existing paradigms. Then humanity faces bigger questions about cosmic isolation and technological primitiveness, and whether we've been observed all along by intelligences we didn't recognize because we weren't looking for the right signatures. Whether the silence we've interpreted as evidence of cosmic loneliness is actually just failure to notice the signals that surround us. Whether visitors have been here before, are here now, will continue coming, and whether we need to develop entirely new frameworks for detecting and characterizing their presence. As the world waits in intense anticipation for that definitive date, telescopes stand ready with observing schedules optimized months in advance. Observers refine the complex models that predict exactly where 3i Atlas will be in the sky at the moment of closest approach, ensuring that pointing is precise and that tracking is continuous through the critical hours when angular separation from Earth is minimized. Simulations run day and night testing different fragment configurations, calculating what the images should look like under various scenarios, preparing comparison templates that will enable rapid assessment when the real data arrives. Some scientists silently pray that Kaku is wrong, that the December 19th images will show fragments, and that the natural interpretation will be vindicated, and that we can return to comfortable understanding where comets are comets, and where alien technology remains safely in the realm of science fiction, rather than becoming documented reality we have to grapple with. They pray because the alternative is terrifying, not in the sense of immediate threat, but in the sense of forced recognition that our cosmic models are incomplete, and that beings far older and far more capable than us have achieved what we're only beginning to imagine. Others quietly pray that he's right, that the nucleus remains intact and that we're forced to acknowledge artificial visitor in our solar system, and that humanity gets unambiguous proof that we're not alone, and that technological civilizations exist, and that interstellar travel is possible, and that the galaxy might be far more populated and active than the silence suggests. They pray because confirmation would answer questions that have haunted humanity for centuries, and because knowing definitively, even if the knowledge is uncomfortable, is better than perpetual uncertainty. Most just pray for undeniable answers, for observations clear enough that interpretation isn't ambiguous, for images with sufficient resolution that fragments are either obviously present or obviously absent without room for arguing about whether marginal features might be separate components or might be irregularities in single nucleus, for data quality high enough that community consensus can form around what we're actually seeing rather than fragmenting into competing factions that each claim their interpretation is correct. Meanwhile, 3i Atlas drifts silently through space, utterly indifferent to human debates about its nature, glowing with reflected sunlight and with the faint luminescence from its coma as volatile ices sublime into the vacuum. Accelerating through non-gravitational forces that might be natural outgassing, or might be controlled propulsion depending on which interpretation proves correct. Shedding mass continuously through those powerful jets that might be random sublimation, or might be precisely directed exhaust from engineered thrusters. The public debate grows louder as December approaches and as awareness spreads beyond specialized astronomical communities to general audiences following the story through science media and social platforms. The stakes grow higher as people recognize that this isn't just academic question about comet classification, but is potentially civilization-defining moment when we learn whether technological intelligence exists beyond Earth. And humanity stands exactly in the same place it has stood 1,000 times throughout history when confronted with potential paradigm shifts, on the edge of fundamental revelation about nature of reality. Terrified to look down into the implications if 3i Atlas is artificial, what it means about our cosmic significance, what it means about whether we're being observed, what it means about the intentions of whoever built it if it is indeed built, what it means for our future as we develop our own capabilities for interstellar exploration and potentially encounter others who achieved that milestone millions of years before us. All uncomfortable questions without obvious answers, yet even more terrified to truly look up and acknowledge what might be there in the skies above us, to accept that visitors might be present. That silence doesn't mean emptiness, that our instruments and our search strategies and our assumptions about what alien technology should look like might have been inadequate all along. That we've been looking for radio beacons and megastructures and obvious signatures while missing the subtle anomalies and the camouflaged probes and the objects that mimic natural phenomena well enough that we dismiss them without careful analysis. The question is no longer whether Kaku is factually correct in his calculations. Those can be independently verified by anyone with physics background and access to the observational data. The mass loss rates are documented. The size estimates come from Hubble observations. The energy balance is straightforward thermodynamics. The 16 times discrepancy follows from that arithmetic regardless of who's doing the calculation. The question is whether we are prepared as global society for what it inherently means if he is correct about the intact prediction. This is where the story stops being merely scientific debate about comet physics and becomes fundamentally existential question about humanity's readiness for cosmic contact. If 3i Atlas is purely natural object that happened to fragment in ways that produce unusual but explainable observations, we will breathe collective sigh of relief. We'll return to comfortable assumption that we're alone, or at least that we haven't been visited. We'll continue searching for radio signals from distant civilizations, while assuming that interstellar travel is too difficult for anyone to attempt, and that if visitors did come, they'd make themselves obviously known rather than operating subtly. If it's not natural, if it remains whole on December 19th despite thermodynamic calculations showing it should have fragmented, if the jets continue to behave like controlled propulsion, rather than like random outgassing. If the mass loss defies the available surface area in ways that no natural process can explain, then the universe is clearly telling us something profound that we can no longer ignore or rationalize away through invoking measurement errors or modeling uncertainties. That technology older than Earth exists somewhere in the galaxy, that the materials comprising 3I Atlas, the systems that might power it if it's artificial, the intelligence that designed it if it was designed, all predate our planet's formation by potentially billions of years. That civilizations rise and fall on timescales that dwarf human history. That technological development continues across eons in ways we're only beginning to imagine as we contemplate our own far future, assuming we survive our current challenges. That intelligence older than humans has crossed our sky carrying purposes we can only speculate about. Reconnaissance, perhaps, gathering data about solar systems and about whether they host life or intelligence. Scientific exploration driven by curiosity about the diversity of planetary systems and stellar environments. Establishing infrastructure for later use, deploying observational platforms or communication relays, or resource extraction facilities that will remain dormant until needed. Seeding stellar systems with probes that activate when they detect technological civilizations emerging, designed to make contact or to observe or to influence in ways we wouldn't recognize as external intervention. That we have entered new chapter of cosmic understanding if 3I Atlas proves artificial. Chapter that begins not with triumphant contact of the kind that science fiction imagined, aliens landing on the White House lawn, radio signals transmitting encyclopedic knowledge, benevolent elder civilizations welcoming us to galactic community. But with quiet, unsettling warning embedded in the physics of an object that shouldn't exist if our models are complete. Warning that we're not alone, that we're being observed, or at least that our solar system has been visited, that the universe is more populated and more active than silence suggested. A final warning in the sense that this might be last chance for establishment science to acknowledge anomalies before being forced by undeniable observations to accept conclusions they've resisted. Final warning before December 19th removes ambiguity and renders debate moot. Final warning from Kaku, who has staked professional reputation on prediction that can be definitively tested rather than remaining perpetually uncertain speculation. In the end, Dr. Michio Kaku didn't issue his final warning to frighten anyone unnecessarily or to generate publicity through sensational claims. He issued it because the cold, hard numbers left him absolutely no place to hide from the logic they demanded. Because the data, cold, silent, and unforgiving in the way that mathematics is unforgiving, had backed him into corner where only two possibilities rigorously remained when you followed the physics to its conclusions. Either the universe is behaving in a bizarre way we have never seen before, displaying novel physics that violates energy conservation, or that enables natural objects to generate 16 times more activity than available sunlight permits through mechanisms we haven't discovered, despite centuries of thermodynamic research and despite countless observations of comets under every conceivable condition. Or 3I Atlas is simply not what we currently think it is, based on cursory classification as interstellar comet, that never examined whether that classification actually fits the full suite of observations. As the comet, or whatever it truly is, whatever designation will prove accurate when we have definitive data rather than preliminary interpretations, drifts inexorably toward its closest approach to Earth, a long trajectory that orbital mechanics predicts with high precision. The world stands suspended between paralyzing dread and imminent revelation, between hope that natural explanation will be vindicated and fear that it won't, between desire for comfortable answers and recognition that truth might be uncomfortable. In observatories across the planet, from Mauna Kea to the Atacama Desert to South Africa to Australia, scientists sit before arrays of glowing monitors in control rooms that never sleep, watching the object inch closer through the sky, pixel by pixel, as successive observations refine its position. Photon by photon, as light that left the object hours ago arrives at detectors and gets converted into digital signal and gets processed into images. Counting down the days and hours until December 19th when distance reaches minimum and when angular resolution reaches maximum and when the moment of truth arrives. They are waiting for the pivotal moment when Hubble and James Webb finally peel back the veil of ambiguity that has shrouded this object since discovery. When instruments that cost billions to develop and deploy will justify that investment by answering questions that theoretical arguments alone cannot resolve. When observations made from Earth orbit and from the gravitationally stable Lagrange point, where JWST stations will provide ground truth about structure that models can only speculate about. For months, they've argued among themselves and in journals and at conferences and on social media. They've written academic papers defending different interpretations, have aggressively dismissed anomalies that didn't fit their preferred models or that challenge their expertise, have defended scientific dogma that assumes natural explanations should always be preferred over artificial ones and that extraordinary claims require extraordinary evidence, have ridiculed unconventional possibilities as speculation unworthy of serious consideration by professional astronomers. But beneath it all, beneath the confident assertions and the dismissive statements and the attacks on Kaku's credibility, even the most conservative researchers feel the same quiet tremor running through them when they're alone with the data late at night. The same nagging doubt about whether their natural explanations really account for everything, or whether they're forcing the observations into familiar categories because those are the categories they know how to analyze. The same uncomfortable question: what if Kaku is right? What if December 19th shows intact nucleus and we're forced to seriously consider that we've been observing artificial object all along? Because everything hinges on one truth that will be laid bare by observations that don't care about our theories or our reputations or our preferences. The truth that no one has been able to decisively refute despite months of trying. If 3i Atlas is still whole when the highest resolution images are captured, the natural explanation dies, not just becomes unlikely or questionable. Dies completely because it requires violating physics that we've verified across billions of independent measurements. Comets do not violate the laws of thermodynamics, do not extract more energy from sunlight than the exposed surface area can absorb according to Stefan Boltzmann law, and according to the solar flux at known distance, and according to the measured albedo. They do not eject more mass than their surface area allows through sublimation rates that have been measured in laboratory, and that match spacecraft observations of dozens of comets under every imaginable condition. They do not fire collimated jets without violently fragmenting under the internal pressure gradients that such jets require. Gas doesn't simply magically flow in narrow beams across hundreds of thousands of kilometers without dispersing thermally unless something is confining it, directing it, controlling it in ways that natural pressure differences don't produce. They do not generate 3 million kilometer anticoma from nucleus too small to physically support it through any known mechanism of cometary activity. They do not mimic the acceleration profile of Oumuamua, the only other interstellar visitor whose behavior was anomalous enough to generate serious speculation about artificial origin. They do not survive stresses that should tear them apart based on structural models validated against observations of countless fragmenting comets. They do not maintain coherent appearance while undergoing activity intense enough to require 16 times the surface area, unless that coherent appearance is misleading, and fragments exist that our instruments haven't resolved. But engineered objects demonstrably do all of these things. Designed, constructed systems built with intents we cannot yet fathom, because we don't know who built them, or when, or for what purpose. Machines operating according to principles that include but transcend natural processes, using power sources and propulsion systems and structural materials that enable behaviors natural objects cannot achieve. And that is the profound fear lurking at the heart of Kaku's final warning. Not fear of immediate threat or of hostile invasion, or of any of the dramatic scenarios that science fiction has primed us to expect. But deeper, more existential fear that we are wrong about our place in the universe, wrong about our cosmic significance, wrong about our assumptions that intelligence is rare and that technological civilization is fragile and short-lived, and that we're among the first to emerge rather than being latecomers to galaxy that's already been explored and catalogued and perhaps even colonized by beings who achieved what we're attempting millions or billions of years before Earth even formed. The fear that we are not unique, not special, not the only conscious observers witnessing the universe and trying to understand it. The fear that some other entity, some intelligence predating humanity by timescales we can barely comprehend, has already done what we are only just beginning to imagine, has achieved interstellar travel, has sent probes across the galaxy, has mapped the stellar neighborhood and characterized the planetary systems and perhaps even visited Earth in our past when our ancestors were too primitive to recognize the visitors or to record the encounters in ways that survive to the present. And if that's definitively true based on observations that remove ambiguity and force conclusions we've resisted, then 3I Atlas is not a comet in any meaningful sense, even if it superficially resembles one. It is not a rock randomly ejected from another stellar system through natural planetary formation processes or through stellar evolution. It is not an accident, not a coincidence, not a product of blind natural forces operating without purpose or intent. It is a relic. An artifact from civilization whose history dwarfs ours the way our recorded history dwarfs the lifespan of individual humans. A mechanism designed and built and launched on mission that might still be ongoing even though its creators might be long extinct or might have transcended into forms we wouldn't recognize. A silent messenger drifting patiently through the stars, moving from system to system across timescales, measured in millions of years, long after its creators completely vanished or evolved beyond needing physical probes to explore the galaxy. It is a machine older than our species, older than mammals, older than dinosaurs, potentially older than complex life on Earth, if it was built by civilization that arose billions of years ago around stars that formed when the universe was young. Revealing just enough to challenge us through the anomalies in its behavior, just enough to force serious scientists like Kaku to consider artificial hypotheses when the natural ones fail, but not enough to fully explain itself, not transmitting obvious signals or displaying clear technological signatures that would remove all doubt about its nature. Maybe that's intentional, maybe that's by design. Maybe whoever built it wanted it to be subtle enough that only civilizations that have developed sufficient observational capability and theoretical understanding would recognize it as artificial. Only species that can detect the thermodynamic impossibilities, and that can calculate the energy balances, and that can appreciate why natural comets shouldn't behave this way. Filtering contact to civilizations that have reached minimum threshold of technical sophistication, rather than revealing themselves to every primitive species that happens to look up at the sky. Maybe that's why Kaku's warning feels less like mere scientific prediction and more like passing of responsibility. Less like, here's my calculation and we'll see if it's right. And more like, I'm showing you what the data demands and whether you accept it or rationalize it away is your choice, but you can't say you weren't warned. A solemn reminder that every so often the universe hands humanity a true test. Not test of raw intelligence or computational power or technological capability, but test of humility. Test of whether we are willing to let go of our comfortable assumptions and genuinely face what is actually in front of us, rather than filtering observations through preconceptions about what's possible or probable or acceptable to believe. Test of whether we can update worldviews when evidence challenges them, or whether we'll defend existing paradigms regardless of how poorly they fit the data. Test of whether we're scientifically mature enough to follow evidence to uncomfortable conclusions, or whether we'll retreat into denial when conclusions threaten our cosmic self-image. And now, as December 19th rapidly approaches, just weeks away as this is being recorded, close enough that observing schedules are finalized and that telescope time is allocated, and that the instruments are being prepared for the critical observations, humanity stands at fundamental threshold. At decision point where reality will assert itself regardless of what we'd prefer to believe. Where observations will either validate natural interpretation that establishment science has defended, or will force serious consideration of artificial hypothesis that most researchers have rejected. Either we will witness disappointing cloud of fragments drifting apart from each other as tidal forces and thermal stresses overcome the weak gravitational binding that held them together. The shattered remains of natural comet that was pushed past its structural limits by internal pressures from intense sublimation as it approached the Sun. 16 or more distinct pieces collectively providing the surface area that thermodynamic calculations demand, proving Kaku right about the physics, while showing that his intact prediction was wrong because fragmentation occurred even though it wasn't obvious in earlier images. Science will breathe collective sigh of relief if that's what we see. We'll return to business as usual with perhaps some interesting papers about unusual fragmenting comet but without fundamental challenge to our understanding of what's possible in the universe. The establishment critics who attacked Kaku will claim vindication. We'll say, we told you it was natural, we told you the artificial hypothesis was premature and irresponsible. We told you that cometary scientists know these objects better than theoretical physicists do. The story will fade from public consciousness as media moves on to next interesting discovery. The brief moment of wondering whether we detected alien technology will be remembered as an instructive example of how speculation can run ahead of evidence. Or we will see something that should not be intact according to any natural process we understand. We will see something that should not be maintaining structural coherence while expelling material at rates requiring 16 times the available surface area, should not be accelerating through non-gravitational forces that create trajectory deviations we can measure but cannot explain through standard outgassing models, should not be shining with the cold, impossible resilience that has defined 3I Atlas from the very start, from the moment of discovery when it should have been typical comet, but instead showed the first hints of the anomalies that accumulated over months until the weight of evidence became undeniable. If the fragments don't appear in the December 19th images, if the highest resolution observations that Hubble and JWST are capable of producing show single coherent nucleus rather than cluster of pieces, if the structure is obviously intact rather than obviously fragmented, then science will face crisis about how to respond. Will establishment figures admit they were wrong, and that Kaku's thermodynamic argument was sound, and that artificial explanation deserves serious investigation? Or will they construct increasingly elaborate natural explanations? Maybe the fragments are there but too close together to resolve. Maybe the size estimate is wrong by factor of 4, making the nucleus actually 23 kilometers instead of 5.6. Maybe the mass loss rate measurements are systematically overestimated. Maybe sublimation physics works differently than we thought for interstellar comets with unusual compositions. If they don't, if the nucleus stands unbroken and whole, then Kaku's final warning will become something far more profound than scientific prediction that proved correct. Will become first real undeniable clue that the universe is not silent empty wilderness, that we've assumed it to be based on absence of obvious radio signals, and absence of visible megastructures, and absence of spacecraft visiting Earth in ways we'd recognize, but instead is vast silent archive of civilizations that came before us. Gallery of technological achievements left behind by species that explored and built and created across eons before our sun even formed. And perhaps 3I Atlas is simply the first page we have managed to turn in that grand ancient cosmic library. First artifact we have examined carefully enough to recognize its artificial nature despite camouflage or despite degradation, from millions of years travelling through interstellar space, exposed to cosmic radiation and micrometeorite bombardment. First messenger from the deep past that has delivered its message in language we could decode, the language of physics and mathematics and thermodynamics that any scientific civilization would understand. Not first visitor necessarily. Maybe others have passed through our solar system over the billions of years since formation, unnoticed because we weren't here to observe them, or because we didn't have instruments sensitive enough to detect them, or because they didn't display obvious anomalies that would make us question their natural classification. But first, that we've studied extensively enough during its passage to compile the data necessary for recognizing what it is. First, where the observations are comprehensive enough, and the analysis rigorous enough that natural explanations fail, and artificial hypothesis becomes not speculative possibility, but logical necessity. If this intense journey through the thermodynamic argument and the scientific controversy and the implications has left you truly thinking about what might be moving through our solar system right now, don't let that sense of wonder disappear into the background noise of daily life. Don't let institutional dismissals or social pressure to accept comfortable explanations convince you to stop questioning when the questions are legitimate and when the answers are uncertain. Subscribe to the channel. Not because I'm telling you what to believe, but because you deserve access to the data and the analysis and the arguments from multiple perspectives, so you can think for yourself about what the evidence supports. The next images, the December 19th observations that are now just days or weeks away, could instantly rewrite the story of interstellar travel and of humanity's place in the cosmic context, could transform 3I Atlas from interesting astronomical curiosity into most significant discovery in human history, could force us to acknowledge that we're not first, not alone, not unique, or could validate natural interpretation and show that even highly anomalous objects can sometimes be explained through conventional physics without requiring technological hypotheses. Turn on notifications because the December 19th data drop might be the single most important astronomical update of our entire lifetime. Might be moment when everything changes or moment when everything stays the same, depending on whether those images show fragments or show intact nucleus. Might be point of historical discontinuity, where humanity's self-understanding undergoes fundamental transformation, or where we get confirmation that our existing models are adequate and that the universe is what we thought it was. And tell us in the comments what you think. Do you believe 3i Atlas will finally break apart under the stresses that Kaku's calculations show should have fragmented it already? Will we see in the December 19th images the cluster of pieces that resolves the thermodynamic paradox through confirming that surface area is larger than single nucleus provides? Or will it stubbornly stay whole, maintaining structural integrity that natural comets shouldn't possess, confirming the warning that Kaku has been trying to give the world through his analysis and his predictions and his willingness to stake professional reputation on conclusions that data demands? This isn't about believing Kaku because of his authority or credentials. This is about examining the evidence yourself, understanding the thermodynamic argument, verifying the calculations, and reaching your own conclusions about what the observations imply. The numbers are public. The images are available. The physics is straightforward enough that anyone with undergraduate science background can follow the reasoning. You don't need to trust experts telling you what to think. You can look at the data and think for yourself about whether natural explanations adequately account for what we're seeing or whether something more exotic is required. As the final days count down to December 19th, as observatories prepare for the critical observations that will settle the question one way or another, the tension is palpable in the astronomical community and in the broader public that's following this story. Social media buzzes with speculation. Betting markets have formed where people are wagering real money on whether fragments will be visible or whether nucleus will appear intact. News organizations are preparing both narratives: the false alarm, it was natural all along story, and the unprecedented discovery of artificial interstellar object story, ready to publish whichever version the data supports. Scientists are writing papers for rapid publication depending on outcomes. If fragments appear, papers explaining the fragmentation process and the structural evolution, and why the earlier observations didn't resolve the individual components. If intact nucleus is confirmed, papers proposing technological mechanisms that could account for the observations and papers arguing for follow-up observations with different instruments, and papers calling for dedicated missions to rendezvous with the object before it leaves the inner solar system. Space agencies are quietly discussing contingency plans. If 3i Atlas proves artificial, should we attempt to send spacecraft to intercept it? The object is moving at 58 km relative to the Sun, far faster than any current spacecraft, but orbital mechanics offers possibilities for rapid mission if we're willing to accept high costs and high risks. Launch heavy payload on trajectory that achieves solar gravity assist, swinging close to the Sun to pick up velocity, then pursuing 3i Atlas on long chase that might take years but that eventually catches up as the object recedes into outer solar system. Worth the investment? Worth the political capital and the budget allocation? And the technical challenges if there's even small chance of getting close-range images or of collecting samples or of detecting signals that might be transmitted at closer distances? Or too risky given uncertainties about what we'd find and about whether approaching alien artifact is a wise idea when we don't know its purpose or its programming or whether it might respond to approach as threat? These conversations are happening in classified briefings and in policy discussions and in strategic planning sessions at NASA and ESA and other national space agencies. Not publicly, not with press releases or announcements, but behind closed doors where institutional leadership weighs options and prepares for contingencies. Because if December 19th confirms artificial origin, the world will demand action. We'll want to know what we're doing about this discovery. We'll expect more than just, "We observed it, and now we're writing papers about what we observed." We'll want engagement, investigation, possibly even attempt at communication, if there's any possibility the object is still active and capable of receiving and responding to signals. But engagement carries risks. Unknown risks because we've never interacted with alien technology before, don't know what protocols exist, what intentions guide its operation, what responses might be triggered by approach or by communication attempts. Maybe it's programmed to transmit information when contacted by electromagnetic signals at specific frequencies, Maybe it's designed to self-destruct if approached too closely to prevent primitive species from accessing advanced technology before they're ready. Maybe it's completely inert, ancient derelict that's been coasting on ballistic trajectory for millions of years and that has no active systems remaining. The uncertainty is paralyzing for decision makers who are accustomed to operating from established protocols and precedents. There is no established protocol for this, no precedent for how to respond to confirmed artificial interstellar visitor. The SETI protocols exist, but they assume detection of radio signals from distant civilization, not physical artifact passing through our solar system. Extending those protocols to this situation requires interpretation and judgment calls that institutions are uncomfortable making without broader consensus about what appropriate response would be. So they wait, like everyone else, for December 19th to provide clarity about what we're actually dealing with. For observations to reduce uncertainty about whether this is natural or artificial. For data to inform decisions that speculation alone cannot support. For reality to assert itself through measurements that don't care about our preferences or our fears or our institutional cultures. The psychological impact of the waiting is significant for people who've followed this story closely and who understand what's at stake. The cognitive dissonance of holding two contradictory possibilities in mind simultaneously, that we might be alone versus that visitors might be here, creates tension that's uncomfortable to sustain. Most people resolve the dissonance by committing to one interpretation or the other, by deciding that it's obviously natural or obviously artificial, based on which conclusion feels more comfortable or more consistent with their existing worldview. But some maintain the uncertainty, accepting that we genuinely don't know yet, and that December 19th will inform us. That both possibilities remain viable until observations rule one out. That the responsible position is suspended judgment, rather than premature commitment to either natural or artificial interpretation, when the evidence that would definitively settle the question hasn't been collected yet. Those people, the ones who can hold uncertainty without needing immediate resolution, who can live with not knowing while waiting for data that will inform rather than speculating based on preferences, are the ones who best understand what scientific thinking actually requires. Not certainty, not unwavering commitment to particular hypothesis, but provisional acceptance of best current explanation combined with willingness to update when better evidence arrives. Comfort with ambiguity until observations remove it. Patience to let reality reveal itself rather than forcing premature conclusions. That's the mindset Kaku has been advocating throughout this controversy. Not, it's definitely artificial and anyone who disagrees is wrong. But the thermodynamics don't work for natural explanation. Therefore we need to seriously consider artificial possibility, and December 19th will show us which interpretation the data supports. Conditional prediction based on rigorous calculation, testable hypothesis with defined criteria for verification or falsification. Exactly what science should look like when confronting anomalous observations. His critics have largely missed this nuance in their rush to defend natural interpretation and to attack what they perceive as sensationalism. They focused on the controversial claim might be artificial, while ignoring the careful reasoning that led to it, have rejected the conclusion without adequately addressing the thermodynamic calculation that supports it, have invoked their expertise in cometary science as sufficient reason to dismiss theoretical physicists' analysis without doing the work of showing where his calculations are wrong. But expertise in observing and classifying comets doesn't automatically translate to expertise in thermodynamic energy balance, or in recognizing technological signatures, or in evaluating artificial hypotheses. Those are different skill sets, different domains of knowledge. Cometary scientists are superbly trained at characterizing natural processes. They're less well equipped to recognize when observations might indicate something other than natural processes because their entire professional framework assumes natural explanations. This is not criticism of their competence. This is recognition that specialization creates blind spots, that becoming expert in one domain can make you less effective at recognizing when phenomena fall outside that domain, that the most rigorous analysis sometimes comes from outsiders who aren't invested in defending existing paradigms and who can apply first principles thinking without being constrained by domain-specific assumptions. Kaku brings that outsider perspective, brings theoretical physics background that emphasizes fundamental conservation laws and energy balance, brings career spent thinking about exotic possibilities like higher dimensions and string theory and quantum gravity, that makes him comfortable entertaining hypotheses that challenge conventional wisdom, brings willingness to follow calculations to conclusions they demand even when those conclusions are controversial. That's valuable contribution to the discussion even if he turns out to be wrong about the intact prediction. Because science advances through this kind of productive tension between specialists defending established models and theorists proposing alternatives that challenge those models, through careful empirical observation combined with bold theoretical speculation, through mainstream consensus that ensures quality control combined with maverick voices that prevent premature closure on incomplete explanations. On December 19th, we'll vindicate one perspective or the other. We'll show who was right about whether 3i Atlas is fragmented or intact. But regardless of which interpretation proves correct, the controversy itself has been scientifically valuable, has forced careful examination of the observations and the calculations, has made the astronomical community think seriously about what technological signatures might look like and how we'd recognize them, has demonstrated that artificial hypotheses for interstellar visitors are not immediately dismissible as pseudoscience, but can be rigorously investigated through proper methodology. That's Kaku's lasting contribution even if his specific prediction fails, showing that questions about artificial origins can be approached scientifically rather than being relegated to fringe speculation. That calculations matter more than authority when evaluating competing explanations. That uncomfortable hypotheses deserve serious investigation when the data warrants it rather than being rejected out of hand because they challenge our cosmic self-image. The days continue ticking down. December 19th approaches inexorably. Astronomers finalize observing plans, optimizing exposure times and filter selections and instrument configurations to maximize the information content of the images they'll capture. Science communicators prepare to explain the results to public audiences eager for answers. Institutions brace for whatever comes next. Vindication or crisis depending on what the observations reveal. And 3i Atlas continues its silent drift through the inner solar system, carrying secrets that might be revealed or might remain hidden depending on whether the December images have sufficient resolution to definitively show structure, carrying mass that might be natural ice and rock or might include technological components, carrying history that might span millions or billions of years if it was launched by ancient civilization, carrying answers to questions humanity has pondered for centuries about whether we're alone and whether intelligence is common and whether technological civilizations achieve interstellar capability. The waiting is almost over. The observations are almost here. The moment of truth approaches when calculations collide with reality and when theoretical predictions face empirical tests, and when humanity learns something definitive about this strange visitor that has captivated our attention and challenged our assumptions for months since its discovery. If fragments appear, we will know that natural processes, however unusual in their details, remain adequate to explain what we observe, that thermodynamic limits apply as Kaku calculated, but that those limits are satisfied through fragmentation providing the necessary surface area, that our cosmic loneliness continues, at least as far as this particular object is concerned, that the search for evidence of extraterrestrial technology must continue looking elsewhere, at radio signals, at optical beacons, at megastructures, at future interstellar visitors that might display more obvious artificial signatures. We will know that Kaku's warning, while well-intentioned and based on sound physics, overestimated the probability that intact nucleus would persist given the stresses involved. That nature found a way to produce the observations through conventional means, even though the configuration required, 16 or more fragments maintaining close proximity, is unusual enough that it wasn't obvious in earlier observations. That the anomalies, while genuine and interesting, don't ultimately point toward technological origin. The establishment scientists who criticized Kaku will claim vindication, though the more thoughtful among them will acknowledge that his thermodynamic analysis was rigorous, and that his prediction was falsifiable, and that the controversy stimulated valuable scientific discussion even if his conclusion proved incorrect. The public will lose interest as the story transitions from possible alien probe to interesting fragmenting comet. Media coverage will fade. Researchers will write papers analyzing the fragmentation dynamics and the unusual characteristics, but without the sense of cosmic significance that artificial origin would have carried. Life will continue as before. Our understanding of the universe will be largely unchanged. The assumption that we're alone, or at least that we haven't been visited, will persist. The search for extraterrestrial intelligence will remain focused on detecting signals from distant civilizations rather than recognizing artifacts in our own solar system. The detection of future interstellar visitors will follow protocols developed for studying natural objects rather than protocols designed to test for artificial signatures. But if fragments don't appear, if the highest resolution images that our most capable telescopes can produce show single coherent nucleus maintaining structural integrity, despite activity levels that should have torn it apart, then everything changes. Then Kaku's warning becomes prophecy fulfilled. Then the thermodynamic impossibility he calculated becomes proof that natural explanations are inadequate. Then the artificial hypothesis transitions from speculative possibility to logical necessity because all the natural alternatives have been falsified. Then we will know with high confidence, not certainty. Science rarely achieves absolute certainty, but confidence approaching certainty given the strength of the thermodynamic argument and the quality of the observations that we are witnessing artificial object of extraterrestrial origin. That technology created by non-human intelligence has entered our solar system and has been observed by our instruments and has been characterized well enough that misidentification is not plausible explanation. Then the implications cascade across every domain of human thought and activity. Science faces paradigm shift, recognizing that technological signatures can appear in our solar system and that we need frameworks for detecting and characterizing them rather than assuming all observed objects are natural. SETI research expands to include search for physical artifacts in addition to electromagnetic signals, recognizing that advanced civilizations might prefer sending probes rather than broadcasting, or that probes might be more common than signals because they're cheaper to deploy and harder to detect. Space agencies face immediate pressure to mount missions to 3i Atlas before it leaves the inner solar system, to collect close-range data before the object recedes beyond reach of our spacecraft. Engineering teams dust off concepts for fast intercept missions, for solar gravity assists that could achieve the velocities needed to catch up with object moving at 58 km/s. Budgets get reallocated, priorities get reshuffled, schedules get compressed as recognition spreads that we have unique opportunity to study confirmed alien technology if we act quickly. Astrobiology expands beyond search for microbial life or biosignatures in exoplanet atmospheres to include consideration of technological life and technosignatures that might be detected through anomalous observations of objects we initially classify as natural. Planetary defense organizations recognize that not all potentially hazardous objects approaching Earth are natural asteroids following predictable gravitational trajectories, that some might be directed and might have capabilities we need to account for in threat assessment and mitigation planning. Philosophy and theology grapple with implications of confirmed alien intelligence, with questions about whether technological capability implies consciousness or moral status or rights, with whether artifacts deserve different treatment than natural objects, with how discovery affects human exceptionalism and cosmic purpose. Religious traditions interpret the finding through their various frameworks, some seeing it as confirmation of divine creation extending beyond Earth, others as challenge to doctrines about humanity's unique relationship with the divine. Government and military institutions assess security implications, asking whether alien probe in our solar system represents threat or opportunity, or something requiring entirely new conceptual categories. Whether its presence suggests we're being monitored, whether its creators are still active or long extinct, whether other probes or other forms of alien presence might exist that we haven't detected, whether disclosure about the finding should be managed carefully to prevent panic, or whether transparent communication is essential for maintaining public trust. International relations face questions about coordination and cooperation, about whether response to alien technology should be managed by individual nations pursuing their own interests or by international bodies representing humanity collectively, about whether space law developed for regulating human activities in space applies to alien artifacts, or whether new legal frameworks are needed, about who has authority to make contact if the object proves capable of communication, who gets access to technology if it can be studied, who benefits from knowledge gained. Economic systems begin processing implications for resource allocation and technological development, recognizing that even ancient derelict probe might contain materials or designs that advance human capabilities if we can access and study them. That confirmed existence of interstellar travel technology even if we can't reverse engineer it, proves it's possible and might stimulate investment in developing our own capabilities. That galaxy containing technological civilizations has profoundly different economic opportunity space than galaxy containing only natural resources. Education systems incorporate the discovery into curricula at every level, from elementary science classes explaining what probes are and why aliens might send them, to university programs in astrobiology and astroengineering and SETI expanding to address newly relevant questions about detecting and characterizing artificial objects. Textbooks get revised, course content gets updated, new specializations emerge as recognition spreads that we're no longer alone and that our place in cosmic context has fundamentally changed. Popular culture absorbs and processes the revelation through science fiction that's suddenly less fictional, through philosophical discussions about what alien technology means for human identity and purpose, through artistic expressions of wonder and fear and curiosity that the discovery triggers. Media coverage continues intensively rather than fading, because unlike most scientific discoveries that interest specialists but don't affect daily life, confirmation of alien technology is a story that everyone cares about and that continues generating news as implications unfold and as follow-up studies reveal more details. All of this cascades from single observation, from December 19th images either showing fragments or showing intact nucleus, from that binary outcome determining whether we validate natural explanation or confirm technological origin, from reality asserting itself through measurements that remove ambiguity and force conclusions that theoretical arguments alone couldn't compel. The magnitude of what hangs on those observations is almost incomprehensible, the potential for civilization-defining discovery contingent on what Hubble and JWST cameras reveal when they capture their highest resolution images of object that might be most significant target they've ever observed. The possibility that humanity's entire future trajectory, our sense of cosmic isolation, our space exploration priorities, our scientific frameworks, our philosophical orientations, might pivot based on whether we see separation between distinct fragments or see unified structure maintaining impossible coherence. That's why Kaku's warning deserves to be taken seriously regardless of whether his intact prediction proves correct. Because he's identified testable hypothesis with profound implications, because he's done the thermodynamic calculation showing that natural and artificial interpretations make different predictions about what we should observe, because he's given us clear criterion, fragmented versus intact, that observations can definitively evaluate without ambiguity or room for interpretation games. That's what makes December 19th so significant scientifically and historically. That's why the observations matter beyond just characterizing another comet or settling academic debate about one object's classification. They matter because they might answer humanity's oldest question about whether we're alone, might provide first definitive evidence that technological intelligence exists beyond Earth, might force us to acknowledge visitors in our solar system and to confront implications we've speculated about, but never had to actually grapple with as documented reality. The universe doesn't owe us comfortable answers, doesn't care whether we prefer cosmic isolation or populated galaxy, doesn't adjust itself to match our expectations or our comfort zones. It simply is what it is. And on December 19th, through observations that capture reflected photons from objects that might be natural ice or might be ancient technology, the universe will tell us something definitive about its nature and about our place within it. Will tell us whether the silence we've experienced is evidence of emptiness or is just our failure to recognize the signs that surround us. Whether advanced civilizations are rare enough that we're genuinely first in our region, or whether they're common enough that artifacts from ancient visitors drift through stellar systems including ours. Whether interstellar travel is so difficult that essentially no one achieves it, or whether it's achievable enough that probe populations exist distributed across the galaxy, will tell us whether Kaku was right to warn us, right to stake his reputation on prediction that most of his colleagues rejected, right to follow the thermodynamics to its logical conclusion even when that conclusion was uncomfortable and controversial, or whether his critics were justified in their dismissal, right to trust their expertise about natural comets, right to be skeptical of artificial hypothesis when natural alternatives existed, even if those alternatives required unlikely configurations. Someone will be vindicated. Someone will face acknowledgement that their interpretation was wrong. The data won't care about reputations or about who wants to be right. won't care about institutional politics or about career implications. We'll simply reveal structure as it exists, fragmented or intact, and let the implications follow from that observation according to logic that Kaku has laid out. And humanity will have to live with whatever answer we receive. We'll have to adjust our self-understanding and our cosmic frameworks to accommodate reality as it reveals itself. We'll have to process the implications, whether they're comfortable or unsettling. We'll have to decide how to respond to knowledge that changes everything, or to confirmation that changes nothing. That moment approaches rapidly. The observations are scheduled, the instruments are ready, the teams are prepared, and 3i Atlas drifts silently onward, carrying its secrets toward the moment when they might be revealed, or might remain hidden when humanity might join the cosmic community of technological species, or might continue our lonely existence as only known intelligence in galaxy that seems empty because we haven't learned to recognize the signs of others. The final warning has been given, the calculations have been shown, the prediction has been made, December 19th will test it against reality, and we will all learn together whether the universe whispered to us through the thermodynamics of impossible comet, or whether nature found a way to produce the observations through conventional means that we simply failed to recognize until the evidence became undeniable. Either way, the search for truth continues. Either way, we will know more on December 20th than we know today. Either way, science advances through testing predictions against observations and updating beliefs based on evidence. That's the process. That's the methodology that has proven more effective than any alternative at revealing how reality actually works, rather than how we wish it would work. And that's ultimately what Kaku's warning represents. Commitment to following that methodology wherever it leads. To calculating thermodynamics rigorously and drawing logical conclusions from the calculations. To making testable predictions that observations can verify or falsify. To accepting whatever answer the data provides rather than filtering evidence through preference for particular outcome. That's the spirit of science at its best. That's the intellectual courage to follow truth even when it's uncomfortable. That's the willingness to challenge consensus when calculations demand it. That's the honesty to admit when we don't know while specifying what observations would resolve the uncertainty. December 19th approaches. The moment of truth nears. The observations that will end speculation and replace it with knowledge are mere days away. The cosmic dice are cast. Reality will reveal itself. And humanity will witness whether we truly are alone, or whether the universe has been trying to tell us something all along through the language of physics and thermodynamics and impossible objects that shouldn't exist if our models are complete. The final warning has been heard. The calculations have been verified. The prediction stands. Now we wait for the universe to answer. Now we wait for reality to speak. Now we wait for December 19th to transform speculation into certainty and warning into either vindication or lesson in humility. The sky awaits. The telescopes stand ready. The moment approaches, and 3i Atlas carries forward, bearing witness to its own nature, ready to reveal what it is through the simple act of being observed with sufficient clarity that ambiguity dissolves and truth emerges. May we have the wisdom to accept whatever truth those observations reveal. May we have the courage to follow the implications wherever they lead. And may we remember this moment, this threshold between knowing and not knowing, this suspension between cosmic isolation and cosmic community, as the time when humanity stood ready to learn something profound about the universe we inhabit and about whether we share it with intelligences that came before us and that left their marks for those patient and careful enough to recognize them. The waiting ends soon. The answer comes, and we will all face together whatever that answer means for our understanding of who we are and where we stand in the grand cosmic story that unfolds across billions of years and trillions of stars. This is the final warning. This is the moment. This is the threshold. And December 19th will tell us which side of that threshold we stand on, alone in emptiness, or accompanied by evidence of others who explored before us and who left their artifacts drifting through the void, waiting for species like ours to develop eyes capable of seeing what was always there.